Hi, welcome to Code with Z. In today's video, we gotta go from this matrix to this, and we have to return this. Now, why should we do that? Because that's what LeetCode 54 spiral matrix is asking us to do. Now, I want you to know that I'll explain and visualize everything in the coming slides, but for the sake of reading the question, let's see what the question is actually asking us for. So as you can see, we're simply given an m by n matrix, and we have to return all of the elements of the matrix in a spiral order. Now, what does spiral order mean? Well, we can understand what that means with this example, and we have this in the slides, so let's check it out there. So I just randomly told you that we gotta go from this matrix to this. This is gonna be the thing that we're gonna return, but like, what is this? Well, this is actually the spiral order of our matrix. So we basically go from here to here, and then we go from 3 to 9, then from 9 to 7, then to 4, then to 5. So we're basically making this shape that you see here. Well, let's see what we mean by this. We said that we're gonna have this motion here, right? So we go from 1 to 3. Well, if we check, we have 1, 2, 3 in the beginning of the array that we gotta return as our output. And then we're gonna go from here to here, like so. And if we check, we're gonna have 6, 9, as you can see here. And then we go from here to this part, so we're gonna have 8 and 7, like so. And then we're gonna get to this 4, like so. So this is the 4 that we have here. And then we're gonna enter this 5, like so. And this is the 5. So basically this array that we have here that we gotta return to solve this problem is representing this motion or shape that we have here. So we go from 1 to 3, and then to 9, and then to 7, and then to 4, and then to 5. So we only have to come up with a code that's gonna do this in our code, literally this, and we're gonna be done with this problem. So let's see how we can do that. These are our motions, right? Let's bring this here. If we check, no matter the matrix, we're gonna always have these movements. We're gonna go from the first row, first column, to first row, last column. And then from first row, last column, we're gonna go to last row, last column. And when we are here, we're gonna go from last row, last column to last row, first column. And when we reach this position, we're gonna get to this row and this column. Now, why do I say this row and this column? Well, we gotta check which one of the columns and rows we've already traversed through. And if we've already been there, we're not gonna go back to there. So we're gonna be like, all right, we know we gotta go up, right? So just go up until you reach a place that we were at. Don't check that. So we're gonna come here and we wanna keep on moving, but would you look at that? We've already been here, right? So we're gonna stop here, and then we wanna go from this row in the first column all the way to this row, the last column. And when we wanna do this, we wanna get to the 6, but we've already been through the 6. If you remember, we went from 3 to 6 and 9, right? So we're gonna stop here, and then we're gonna have this motion like so. To be able to implement this with our code, we're gonna need 4 simple variables. We're gonna have a variable called top, we're gonna have a variable called right, we're gonna have a variable called bottom, and we're gonna have a variable called left. And these 4 variables are gonna get updated throughout our code. So for example, when we start, our top is gonna be here, and it will allow us to go through here because we've never been here, right? But when we actually do, we're gonna update the value of our top, so it will not allow us to come back here. These 4 variables are gonna help us with our navigation. So we literally went from left top to right top, right? And then we go from right top to right bottom. And while we do these movements, we make sure that we update the values in our variables to prevent us to go back to the same places that we've been at. And then we go from right bottom to left bottom, like so. And then from left bottom, we go to left top. This time, left top is gonna be here because we've updated our top and it will not allow us to get to this part. And then we go from left top to right top, but again, we've updated our right and it will not allow us to get to the 6 here. So this is gonna be our logic. Now let's code this in the simplest way possible. Alrighty, so let's define our variables first. So we're gonna have top, and this is gonna be equal to 0 because again, the index of this row in the beginning is gonna be 0, right? And then we're gonna have left, and left is also gonna have the index of 0 because we're gonna start from the first column and first row, right? And then we're gonna have bottom, and bottom is gonna be basically the last row, right? Literally bottom is gonna be here, so it's gonna be the last row. So bottom is gonna be equal to matrix.length minus 1, like so. And this is gonna basically give us the last row in our matrix. And then we're gonna have right, and if you remember, right was equal to the last column. So we have left, top, right and bottom. Right is obviously in the last column, right? So we're gonna say right should be equal to matrix at the index of 0 dot length minus 1. And this is basically like saying right should be equal to the last column. And then later on in our code, we're gonna need to know the size of our matrix. So we're gonna say const size. We're basically getting this m multiplied by n that we have here. So we're gonna say matrix dot length multiplied by matrix at the index of 0 dot length. And this is literally like saying rows multiplied by columns. So for example, if we have 3 rows and 3 columns, the size of our matrix is gonna be 9. And then as you saw, we're gonna need to return an array, right? So we're gonna call a result and we're gonna initialize it to an empty array. This array that we have here basically represents the array that we're gonna return at the end that we saw in the slides. And then we're gonna have our loop because we have to loop through this matrix and we have to recreate this motion that we have here. So to define our loop, we're gonna say while, and then we're gonna have a condition that we need to write here, and we're gonna keep on looping as long as this condition is true. But what should that condition be? Well, we wanna keep on looping inside of this matrix until we reach this answer, right? When we've actually went through all of the cells or all of the numbers inside of our matrix, we want to stop looping, right? In that situation, that means we've already added all of the values that we have inside of our matrix to our result. The length of our result array is going to be equal to our matrix size. So we're going to say we want to keep on looping as long as result dot length is smaller than the size of our matrix. This basically means we're going to keep on looping as long as our result is smaller than the size of our matrix, because if the result is actually equal to the size of our matrix, that means we've actually went through all of the cells that we have here and we have an answer to return. So here we have to update our top, right, bottom, and left values to recreate this motion that we have here. We're going to use 4 simple separate for loops for each one that we have here. So let me show you. The first thing that we need to do is to go from here to here. So we basically go from left to right. So let's literally say that. We're going to say for let I being equal to left, because we start from left and we want to keep on looping as long as I is smaller than right. And then we want to keep on incrementing I on each round. And here we're going to have one simple line. We have to go from here to here. Well, let's see how we can actually do that. So we have our matrix, right? It's going to have a row value and a column value. If we check here, we're not going to change rows, but we're going to change columns. We're going to go from the first column in our top row to the last column in our top row. So we're going to say our row is going to be top, but we want to make this dynamic. So we want to make the columns dynamic, and that's why I gave it I. So literally in the beginning, we're going to have this value and then this value and then this value. And that's because our row value is going to stay the same, but our I is going to change. And when we go through these cells, we want to add these numbers to our result array. As you can see, we add 1, 2, 3 to our result array like so. So we're going to say when we are actually looping, we want to push all of these inside of our result array like so. And when we're done, we've actually covered the first row. So we're going to increment top so we can actually make top get to this row because we've already covered this row, right? And then when we actually reach here, we want to go from this position to this position. So we basically go from top to the bottom, right? So we're going to literally say that. We're going to say for let I being equal to top, and we want to keep on looping as long as I is smaller than the variable bottom, and we want to keep on incrementing I on each round. And then here, we're going to say result dot push matrix, but let's see what we should actually push. We need to give a row value and a column value. Well, let's check. When we go from here to here, our column is going to stay the same thing, right? We're only changing rows. So our column is constant, but we want our rows to be dynamic. So we're going to say our column should stay as it is. And our column is going to be right, but we want our rows to change. So we're going to put I in the position of the row. But our column is going to be right. As you can see, we're going to be in the column that right is pointing to, but we want to change our rows. And when we're done, we want to decrement right. Why? Because we've covered this right side of our matrix. Then we're going to go from this side to this side. So we're going to go from right to left. So let's literally type that. We're going to say for let I being equal to right, and we want to keep on looping as long as I is greater or equal to left. Because this motion is going to be from right to left, we got to say we want to keep on looping as long as I is greater or equal to left, and we want to decrement I on each round. It's going to be a reverse loop basically, because we're going from right to left. Here we're going to have our result.push matrix, and we have to give it its two values. Well, let's see. In this motion, our row is going to stay the same thing, but our column is going to change. Our row is going to be bottom, because if we check this picture, we can see that this row is going to be our bottom row. So we're going to say row should be constant and it should be equal to bottom, but we want to change our column, and that's going to be I. When we're done with this, that means we've already covered the bottom row. So we want to update our bottom variable. So when we actually reach this position, we have to go from here to here. So you have to make this movement. We're going to go from bottom to top, right? So we're going to say for let I being equal to bottom, and we want to keep on looping as long as I is greater or equal to top, and we want to keep on decrementing I on each round. Because remember, when we go from right to left or from down to up, we're going to decrement our I. Here we're going to say result.push, and we're going to have our matrix and its two values. Let's see what values we should give to our matrix. So if we go from this position to this position, our column is going to stay the same thing, but our row is going to change. So our row should be dynamic, so I'm going to give it I, but our column is going to stay as it is, and our column is going to be left. Because if you check, this is going to be our first column, and our left variable is going to be pointing to this column that we have here. We're going to have this, and when we're done, we're going to increment it like so. These four for loops are literally going to make this motion that we need here. And each time it's going to repeat it on itself. When this condition is not going to be true, we're going to exit our loop. But when we're pushing numbers to our result array in these for loops, we need to make sure that this condition here stays true. So we're going to have the same thing. We're just going to copy, and then we're going to say, and this. Basically, we're going to keep on looping as long as I is smaller than right and result.length is smaller than the size that we have. Simple as that. We're going to add these to all of our for loops, and this is gonna be the last thing that we do, like so. And then at the end, we're gonna return our result. This is gonna be all of our code, but I forgot to add the equal sign here. We wanna keep on looping as long as I is smaller or equal to right or bottom. As you can see, we have the equal signs here as well. And now let's run it and see if we're gonna get accepted. Moment of truth. I hope I have not made any other typos. Yep, as you can see, we got accepted. Let me submit it. Moment of truth. Let's see if we're going to pass all of the test cases. And yep, and we got accepted. That's awesome. Thanks for watching. Don't forget to like and subscribe and keep on coding.